Welcome everyone. My name is Davide Spadini and I'm a PhD student at Delft University of Technology and a researcher at SIG. Today I will present a paper called Primers or Reminders, the effects of existing review comments on code review. Let me start with the background first. We all know how peer review of manuscript works. We all have done it at least once. The process of reviewing a manuscript is a lot similar to the code review process. For example, in both cases it's asynchronous, so the authors submit the manuscript or the code and then the reviewers asynchronously perform the review. Each review has generally more than one reviewer. In the case of manuscript, it's generally 3 reviewers, while for the code review, it depends on the project. For example, in one of my previous studies, I showed that Eclipse, Qt, and OpenStack have in general between 2 or 3 reviewers per review. On the other hand, there is one big difference between these 2 review processes. In the case of peer review of manuscript, the reviewers independently judge the document. It is common that the reviewers don't see each other's reviews until they submit one. On the other hand, in the code review process, reviewers can immediately see each other's comments on the code. Could this visibility bias the other reviewer's judgment? In this study, we investigated availability bias in the code review. Availability bias is one of the cognitive biases, and it's defined as the tendency to overestimate the likelihood of events with greater availability in memory. In other words, when making a decision, we tend to use information that comes to mind quickly and easily, such as things that happened recently. In this study, we argued that when doing a code review, the reviewer, by reading the other reviewer comments, might be biased in finding the same types of errors, while neglecting others. If this hypothesis holds, we might need to reconsider how the code review process works, and maybe change it to something more similar to a manuscript review. Hence, in this study, we wanted to investigate the impact of availability bias in the code review. Namely, what is the effect of priming the reviewer on a specific bug type? Is the reviewer gonna catch similar bugs more often than others? However, not all the bugs are the same, and during code review, some bugs are usually more checked than others. For this reason, we split our main research question into 2. What is the effect of priming the reviewer with a bug type that is and is not normally considered? To answer these 2 research questions, we devised an online control experiment. First, the participants were asked to answer a small survey with demographics questions. Then, participants were randomly selected for the treatment or control group. In the treatment group, participants were primed towards a type of bug by showing them another reviewer comment on the same type of bug. In the control group, instead, no comments were shown to the participants. Then, each group was split into 2 different groups, one for each code patch. For RQ1, the patch included a not normally considered bug, and in this case we took a null pointer exception on parameters. Both gray and white literature account null pointer exception on parameters as not typically considered during code review. For RQ2, the patch included a normally considered bug, and in this case we took an issue with a corner case, and this bug, on the other hand, are typically checked. For example, the Google code review guidelines encourage reviewers to check for such cases. For example, how the code behaves with an empty array, empty string, or an interval flow. Finally, all the participants were asked to answer some questions on the code review, and in this case we asked them whether they captured the bug, and if they were in the treatment group, whether they catch the bug thanks to the comment or they were somehow influenced by the comment. If they are in the control group instead, we just asked them whether they found it, and if they did not find it, why. To give you an example, this is one of the 2 code patches, and you can see we are in the treatment group because a comment is already shown, and it's about a corner case bug. In this code, there is another corner case bug, and it's here. This line should be greater than 0 and not greater or equal than 0. So if the participants are primed towards this bug type, maybe they are gonna miss another bug, and it's in these lines because this might give null pointer exceptions. Let's move to the results. In this table, we can see the results of our statistical model. Our independent variable is called isPrimed, and it's true or false depending on whether the participant was primed on a type of bug or not. We also have many dependent variables such as experience in Java or code reviewing. As we can see from this table, isPrimed is statistically significant for the primed bug, that is the bug of the same type of the comment shown on the screen, but it's not for the non-primed bug. This indicates that the participants in the treatment group found more often the bug of the same type than the participants of the control group, but found the same amount of time the other bug. When we asked the participants whether they were influenced by the comment, 20% replied extremely influenced, 40% very influenced, and 20% somewhat influenced. To sum up, reviewers primed on a not commonly considered bug are more likely to find other occurrences of the same type of bug. However, this does not prevent them in finding also other types of bugs. If we move to the commonly checked bug, priming the participants on a specific bug type do not seem to have an effect on the amount of bugs they catch. Both groups found the same amount of bugs, independently to whether they were primed or not. In this case, when asked whether they were influenced by the comment, 50% replied extremely influenced, 10% somewhat influenced, and 40% slightly or not influenced at all. To sum up, reviewers primed on an algorithmic bug such as a corner case perceive an influence but are as likely as others to find algorithmic bugs. Furthermore, primed participants did not capture fewer bugs of the other type. To conclude, in the case of a not commonly checked bug, developers did find more bugs of the same type, but this did not prevent them in finding the other type as well. Hence, in our experiments, we did not find evidence of a strong negative effect of reviewers' availability bias. In other words, reviewers do not seem to be influenced by reading each other's comments. On the other hand, comments might act as reminders rather than primers. By reading the comment, reviewers were catching more times a bug that they would not normally consider, while catching the same amount of time the other bugs. To sum up, we wanted to study availability bias in code review and see whether reviewers were influenced by reading each other's comments. We designed a study with two research questions. One, to see the effect of priming a reviewer with a comment on a bug type that is not normally considered, and the other one for a bug type that is normally considered. In the case of the not normally considered bug, we saw that comments act as reminders rather than primers and remind the reviewer of this bug type. In the case of the normally considered bug, instead, comments do not seem to have an effect on reviewers. Thank you for your attention.